Good day, everyone. I'm Abdul Jafri, and I will begin our presentation on the case study of hazard identification, risk assessment, and risk control at laboratory workshop, and conducted at the FKTE building. This is our group. Our group name is Spark, and we are 5 members here. First, let's understand why OSH, occupational safety and health, is important in engineering environments, especially in laboratories like FKTE. Students and staffs are exposed to electrical, mechanical, and chemical hazards. To ensure safety, we follow Malaysia's OSHA 1994 and FMA 1967 regulations. HIRAC is a key process that helps us systematically identify risk, assess their severity, and apply suitable control measures. It is more than just compliance, it's about creating a safety culture. So this the case study focuses on FKTE lab, which is designed for courses like electrical circuit analysis, robotics, and microcontroller programming. The lab holds up to 30 students and is equipped with machines such as oscilloscopes, PLCs, soldering stations, and robotic arms. For the classification activities from most hazardous to least hazardous, at the top are CNC and robotics arms operations, followed by high voltage experiments, soldering, soldering and assembly. Then hazard 4 is handling solvents or cleaners. Hazard 5 is computer based simulators. Now my teammates will walk you through the specific hazards and how we can control them.
Okay, thank you, Jeffrey. So I will now present the first two hazards we identified in our laboratory. So for the hazard one is electrical shock from high voltage experiments. This is usually due to common activity in our lab, and the main cause is contact with the live circuits. Apart from that is poor insulations and lack of proper procedures as well. So the risk level is quite high because electric shock can lead to severe outcomes like burns and cardiac arrest as well. So to control this kind of hazards, we apply three safety measures, which is engineering controls like installing insulated barriers and earthing, proper earthing, which is installation of ELCB. And apart from that is administrative controls, which includes strict SOPs and supervisions. And apart from that is by wearing PPEs, which is personal protective equipment like gloves, dielectric shoes, and safety glasses. So moving on to the hazard 2, which is solder burns. So this happens when students touch any hot soldering irons or get splashed by molten solders. The risk is quite medium, but still dangerous, especially for beginners. So what can we do to manage this is first by installing heat-resistant soldering stations and organized workspace. Apart from that is safety training and signage. And besides that is the equipment of PPEs like gloves, goggles, and long sleeves. So with these kind of measures, we can aim to reduce the injuries and promote a safer practice. So that's all from my side. Thank you.
Thank you, Avinish. I will now explain the next two hazards, fire and mechanical injury. Hazard 3 is fire due to flammable materials like isopropyl alcohol or acetone, poor ventilation of faulty electrical wiring increases the risk, although the likelihood of fire is low, the impact is very high. It could destroy lab equipment or injure people. Our fire hazard controls include using safer chemical alternatives, fireproof cabinets, ventilation systems, and extinguishers, emergency drills, and PPF like flame resistant coats. And next, moving on to hazard 4, which is mechanical injury from CNC machines or robotic arms. This hazard occurs when someone accidentally touches moving parts or bypasses safety guards. Injuries could be as serious as fractures or even amputations. Therefore, controls include installing emergency stop buttons and interlocks, allowing only trained operators to handle machinery. PPE like safety shoes, gloves, and fitted clothing, safety awareness and discipline are key to avoiding mechanical injuries in the lab.
Thanks, Madis. Now I'll continue with the final hazard, which is the hazard 5, chemical exposure. So this mostly happens when cleaning agents like isopropyl alcohol, our agents like isopropyl alcohol are used. These chemicals can cause skin irritation and dizziness or even serious respiratory issues. We can control this hazard by substituting less harmful chemicals or using fume hoods and proper ventilation. Make MSDS is known as Material Safety Data Sheets, accessible and ensuring correct labeling. What else we can do is wearing nitrile gloves, lab coats, and goggles. So these are the hazard 5 chemical exposure. Now I'm going to move on to the final, which is the discussion part. Uh, so first is applying hierarchy not only complies with law but also builds a strong safety culture. Student needs to learn to assess risk, follow safety protocols, and become one more responsible engineers. On a broader level, it reduces accidents and medical costs less. Okay, so it protects the environment from spills or pollution. It encourages sustainable lab practices, and FKTE lab becomes a model for safety by teaching real-world hazard and management skills to students. That's all from me. I'll pass on to my next friend. Thank you.
Thank you, Samuel. I will conclude our presentation. This case study clearly shows how systematic application of HIRAC helps maintain a safe learning environment in the FTKE lab. We identify 5 major hazards: electrical shock, soldering burns, fire hazard, mechanical injury, chemical exposure. For each, we applied layered controls, engineering administrative, and personal protective equipment. While we cannot eliminate all risks, we can reduce them significantly. More importantly, HIRAX instills lifelong safety habits in future engineers. It helps them think critically, act responsibly, and contribute to safer workplace after graduation. FTKE Lab sets a strong example by prioritizing safety and preparing students for the real world. And that's it. This is the end of our presentation. Thank you for your attention.